Good morning, class. In our yesterday's class, we have seen the isomerism and its classification, and we have classified the isomerism into two different types, and we classified isomerism first as structural and then stereoisomerism. Then structural isomerism can further was classified into 6 types, which we have already seen: chain, position, functional, metamerism, ring chain, tautomerism, and all. Okay, now today we are going to discuss about stereoisomerism, the second type of isomerism. So stereoisomerism means when the same molecular formula represents two or more compounds which differ in the spatial, that means space arrangement of atoms or groups, then such compounds are called stereoisomers, and the phenomenon is known as stereoisomerism. And again, this stereoisomerism has been classified into 2 types, as we know: geometrical and optical isomerism. So we'll first study about geometrical isomerism. Geometrical isomerism means when the same molecular formula represents two compounds which differ in the spatial arrangement of atoms or groups around carbon-carbon double bond. Just remember this term, carbon-carbon double bond. Then such isomers are called geometrical isomers, and the phenomenon is called geometrical isomerism. And this geometrical isomerism is due to the restricted or hindered rotation around the double bond. So if you have got a single bond, then the atoms around it can be rotated in the molecule, whereas when you have got a double bond, that rotation is hindered. That means it does not allow that rotation. So geometrical isomerism will take place only where we have got a carbon-carbon double bond. Okay, now what are the conditions necessary for geometrical isomerism? So the conditions that are necessary for geometrical isomerism are: the first one, number one, the molecule must have a double bond. That is the first criteria. And number two, there must be two different atoms or groups attached to each carbon atom of the double bond. So there must be two different atoms. Okay, two different atoms or groups which is attached to each carbon atom. Say for example, if you see this 2-butene. Okay, so I have written the butene in this form. So where we can see that we have got a carbon-carbon double bond, and on either side we have got a methyl group, which you have circle. Okay, methyl groups. And on the other side, in trans butene, we can see that the two methyl groups are opposite to each other. Now the two similar groups which are on the same side, they are called as cis isomer. Cis means same. So this structure is cis-2-butene. Whereas on the right hand side, if you see, then the two methyl groups are on the opposite side. So the isomers in which the groups are on the opposite side, they are called as trans-2-butene. Now they are called as trans-2-butene. Now based on this understanding of geometrical isomerism, we have got assignment 8. Question number 1, define stereoisomerism. Question number 2, what is geometrical isomerism, and what are the necessary conditions required for geometrical isomerism? And question number 3, define cis and trans isomer. Just now I have explained. And question number 4, write the geometrical, or that is cis and trans form, trans isomer. Write the geometrical, that is cis and trans isomer of the following compounds: 1,2-dichloroethene, but 2-ene 1,4 dioic acid. Okay, so you need to write this as you have seen in the example. So complete this assignment and send it.